the self-feeding 500-year-old protein system that outproduces any modern farm. Imagine this scenario. It is late August, the sun is brutal, and you are standing in a quarter-acre pasture watching a single steer chew grass. You have been feeding this animal for 18 months. You have spent thousands on fencing, hay, vet bills, and water. If everything goes right, you will get about 200 pounds of beef off that quarter acre this year. Now picture your neighbor. She has a hole in her backyard about the size of a large bedroom, maybe 10 feet by 15 feet, filled with water. She dug it one weekend. She does not feed anything in it. She barely touches it. And that tiny, quiet pond is producing more harvestable protein per year than your entire pasture. More protein, 1/10 the space, and almost zero labor. What does she know that you do not? She knows a system that is roughly 500 years old, documented by a Chinese statesman named Fan Li around 460 BC in a treatise called the Yang Yujing. It is the oldest known manual on freshwater aquaculture. And the core principle it teaches, stacking multiple species in a single body of water so they feed each other, is so efficient that modern university research still cannot beat it with technology. Here is what you are going to learn today. You are going to learn the biology that makes a pond feed itself, the exact construction method, the species that do the work, and the sequencing that keeps the whole system from crashing. By the end of this, you will understand why a 400 hole in the ground can replace a 15 zero-hour livestock operation. Let us start with the numbers, because the numbers are what make this hard to ignore. University Extension research on low-intensity pond aquaculture documents yields of 100 to 500 pounds of fish per acre per year in simple, unaerated ponds with minimal feed input. Scale that down. A 150 square foot backyard pond is roughly 1/290th of an acre. Even at the low end of those yields, you are looking at meaningful protein from a space smaller than most living rooms. Meanwhile, pasture-raised beef production in the United States averages somewhere between 30 and 70 pounds of meat per acre per year, depending on the operation. Pond aquaculture can exceed that by a factor of 5 to 10 in the same footprint. The physics of why are simple. Fish are cold-blooded. They do not burn calories keeping their bodies warm. A cow spends roughly 70 of its caloric intake just maintaining body temperature and moving a 1 pound frame around a field. A fish converts feed to flesh at a ratio of about 1.5 to 1. A cow converts at roughly 8 to 1. That thermodynamic difference is the entire story. Here is method number 1. Understand the invisible engine before you build anything. The reason a pond can feed itself comes down to one biological cycle that most people have never heard of, the nitrogen cycle. Here is how it works. Fish produce ammonia as waste. Ammonia is toxic. In a bathtub, it would kill them in days. But in a living pond, a colony of naturally occurring bacteria called Nitrosomonas converts that ammonia into nitrite. Then a second group called Nitrobacter converts nitrite into nitrate. Nitrate is plant fertilizer. Your aquatic plants absorb the nitrate, clean the water, grow biomass, and that biomass feeds insects, zooplankton, and smaller organisms which feed the fish. The fish produce more ammonia. The cycle repeats. This is not a metaphor. This is a real chemical loop that runs on solar energy and biological labor. Once it establishes, and it takes about 4 to 6 weeks, you have a system that processes its own waste and generates its own food with no external input. That is the engine. Everything else you build is just giving that engine the right housing. Method number 2, build the pond so thermodynamics work for you, not against you. Location matters more than size. You want a spot that gets 6 to 8 hours of sunlight daily because sunlight drives photosynthesis, which drives oxygen production, which keeps everything alive. but you do not want full sun all day. Water above 85 degrees Fahrenheit holds less dissolved oxygen, and oxygen-starved water kills fish faster than almost anything else. Partial afternoon shade is ideal. Choose the lowest natural point on your property where rainwater already collects. Fighting gravity and natural drainage is a war you will lose over 10 years. For a family scale system, dig roughly 10 feet by 15 feet. The center must be 4 to 5 feet deep. Here is the physics. Water has enormous thermal mass. A body of water 4 feet deep resists temperature swings far better than one that is 2 feet deep. That thermal stability is what lets fish survive summer heat and winter cold. The deeper center acts as a thermal refuge. Around the edges, create a shelf about 1 foot deep and 2 to 3 feet wide. This shallow perimeter is your marsh zone. It is where your plants will root, and it is where the richest biological activity happens because shallow water warms first, driving the fastest microbial and plant growth. If you have heavy clay soil, you can seal the bottom the way people have done it for millennia with 6 inches of compacted wet clay. Pack it down hard. Let it cure. It works. If your soil is sandy or rocky, use a rubber pond liner. They run about 1 to 2 per square foot and last 20 to 30 years. If you fill with municipal water, let it sit for a full week before adding anything alive. Chlorine is a disinfectant. It kills bacteria, which means it kills your nitrogen cycle before it starts. A week of sitting lets the chlorine off gas naturally. Well water or collected rainwater can be used immediately. Method number 3, install the biological filtration system, which is just a fancy way of saying plants. This is where most people make the mistake of thinking plants are decoration. They are not. They are the kidneys and lungs of your pond. Cattails planted on your shallow shelves pull excess nitrogen and phosphorus directly out of the water through their root systems. This prevents algae blooms, which are the #1 killer of backyard ponds. An algae bloom is not just ugly. When the algae dies, its decomposition consumes all the dissolved oxygen in the water and your fish suffocate. Cattails prevent that by outcompeting algae for the same nutrients. Water lilies provide surface shade. Shade lowers water temperature and reduces evaporation, which matters enormously in July and August when you can lose an inch of water a day to the sun. Submerged plants like hornwort release oxygen directly into the water column during daylight hours through photosynthesis. This is your aeration system, and it costs nothing to run. Then there is duckweed. Duckweed is a floating plant so small that most people think it is algae. It is not. It is the fastest growing flowering plant on Earth. Under good conditions, it can double its biomass in 24 to 48 hours. Its protein content can reach 25 to 45 of dry weight, which rivals soybeans. It absorbs nutrients at a rate so aggressive that wastewater treatment plants use it to clean contaminated water. In your pond, it is free fish food and free duck food that manufactures itself faster than anything can eat it. Install plants first, before any animals. Give them 2 to 4 weeks to root, spread, and start the biological filtration process. The bacteria need surfaces to colonize, and plant roots provide exactly that. Method number 4, stock fish using the polyculture principle, not the pet store principle. The genius of the ancient Chinese system that Fan Li documented and that the Tang dynasty accidentally perfected was not putting fish in a pond. Anybody can do that. The genius was putting the right combination of species that occupy completely different ecological niches so they never compete with each other for food. During the Tang dynasty, roughly 618 to 907 AD, an imperial ban on farming common carp forced farmers to experiment with multiple species in the same pond. They discovered that mud carp fed on bottom sediment Silver carp filtered algae from the mid-water, grass carp ate surface vegetation, and bighead carp consumed zooplankton. Every layer of the water column was being harvested by a different mouth. Zero competition, zero waste, maximum protein output from the same volume of water. For most of the United States, your practical species are bluegill and channel catfish. Bluegill reproduce on their own, require zero supplemental feeding, and reach harvestable size in about 2 years. They are the set-it-and-forget-it protein source. Channel catfish grow faster, reaching 1 to 2 pounds in about 18 months. If you are in a warm climate where water stays above 55 degrees Fahrenheit year-round, tilapia are the fastest option. They can hit a full pound in 5 to 6 months. But check your state regulations before buying tilapia fingerlings. They are restricted or banned in many states because they can become invasive in warm waterways. Bluegill and channel catfish are legal in nearly every state. Stock roughly 50 fingerlings per one. 0 gallons of water. Resist the urge to overstock. More fish means more ammonia, which means more strain on a nitrogen cycle that has not fully matured yet. Start conservative. Method number 5. Add the biological managers, which are ducks. This is where the system shifts from clever to brilliant. Ducks are not just egg producers, though they are very good at that. They are active participants in the pond's biology. When ducks swim, their paddling feet stir bottom sediments, releasing trapped nutrients back into the water column where plants and bacteria can process them. When they defecate, and they do this constantly, they add raw organic nitrogen directly into the system. That nitrogen feeds the algae and duckweed. The duckweed feeds the ducks and fish. The fish waste feeds the bacteria. The bacteria feed the plants. It is a closed loop. A small flock of 3 to 5 ducks is ideal for a pond this size. They will also provide eggs. A productive laying breed can produce 250 to 300 eggs per bird per year. 3 ducks means 750 to 900 eggs annually, which is roughly 60 to 75 eggs per month, from animals that are foraging a significant portion of their own diet from the pond ecosystem. Research on ducks with access to pond systems shows they can naturally forage roughly 30 of their daily nutrition from insects, aquatic plants, and small organisms. That is 30 less feed you need to buy. Pro tip: introduce ducks about a month after your plants are established, and then wait another full month before adding fish. The sequencing matters. Plants anchor the filtration, ducks activate the nutrient cycle, and fish arrive into a system that is already stable enough to handle them. Method number 6. Survive winter without losing your stock. If you live somewhere that freezes, this is the question that decides whether your system is a year-round food source or a seasonal project. Here's the good news. Bluegill and channel catfish are cold hardy. When water temperature drops below about 50 degrees, they enter a dormant state. Their metabolism slows to almost nothing. They stop eating. They hover near the bottom of that deep center zone you dug. They can survive under ice for months. The danger is not the cold itself. The danger is gas exchange. Under a sealed sheet of ice, decomposing organic matter on the bottom produces gases, including ammonia and hydrogen sulfide, that have no way to escape. Those gases build up and poison the water. All you need to prevent this is one small opening in the ice. A floating pond de-icer or a simple low-wattage air pump with a bubbler will keep a hole open all winter. Tilapia cannot survive cold. If you chose tilapia and you live in a freeze zone, harvest your entire stock before water drops below 55 degrees. That is your annual harvest event, and it can yield 40 to 50 pounds of fish from a modest pond. Ducks handle cold remarkably well. A basic 3-sided shelter packed with dry straw is sufficient. They will continue laying through winter with minimal drop in production. Method number 7, harvest without destroying what you built. The most common beginner mistake is harvesting too aggressively. If you pull out every large fish, you remove your breeding population and the system cannot replenish itself. The rule is simple. Never harvest more than 30 to 40 of your estimated fish population in a single season. Leave the mature breeders. Leave the juveniles. The pond will refill itself. Bluegill are especially forgiving here because they are prolific breeders. A single pair can produce thousands of fry in a season. You literally cannot eat them faster than they reproduce as long as you leave enough adults to spawn. Pro tip: the best time to harvest is late summer or early fall, when fish are at peak weight from a full growing season. A simple cast net or a baited fish trap works. No special equipment required. Now, a critical note on safety. If you add any mechanical aeration, a pump, a bubbler, an aerator, any device that runs on electricity near water, you need a ground fault circuit interrupter on that outlet. Period. Electricity and water kill people. A GFCI outlet costs $15 and takes 10 minutes to install. Do not skip this. Also, if you have small children, a pond is a drowning hazard. Treat it exactly the way you would treat a swimming pool. Fence it, supervise it, or cover it with rigid netting. No exceptions. Here is what you now know. You know that a pond feeds itself through a nitrogen cycle that runs on sunlight and bacteria. You know that cold-blooded fish convert feed to flesh 5 times more efficiently than cattle. You know that a 150 square foot pond built for 400 to 600 can produce more usable protein per year than a quarter-acre pasture that costs 20 times as much to maintain. You know the species, the sequencing, the construction, and the harvest rules. This is a 500-year-old system. It fed civilizations through wars, famines, and collapsing empires. It works because the biology has not changed. Bacteria still convert ammonia, plants still absorb nitrate, fish still grow. You do not need a farm. You need a hole, some water, and the patience to let biology do what it has been doing for a very long time. Stay fed, stay prepared.